It can shatter in a moment, yet it is crafted to outlast stone. Humanity generates a staggering 2 billion tons of waste each year, and glass accounts for nearly 20% of that colossal figure. A single discarded bottle can sit in the earth for over 1 million years without breaking down, a near-permanent relic of our modern world. But this material holds a remarkable secret. Glass can be recycled forever, reborn time and again, without any loss of its inherent quality or purity. The journey from messy, broken shards back into clean, shiny bottles is a testament to this unique potential. This transformation unfolds inside one of the world's largest glass recycling factories, where hundreds of tons are brought back to life every single day. Here we uncover the secrets behind the unbelievable journey of one of the most sustainable materials on Earth. An object designed to be discarded, yet it holds a hidden currency. The lifeblood of glass recycling is a steady supply of used bottles, but when they are mixed with household waste, sorting becomes a costly and complicated task. In many parts of Europe, an elegant system intercepts these containers right at the source. Automated return machines dot city streets, inviting people to deposit their empties. An internal scanner identifies each bottle before it is sorted, and the machine dispenses a small refund, usually around 10 to 20 cents. This simple transaction transforms a finished bottle from potential waste into a tangible asset, encouraging public participation and providing factories with a continuous flow of glass that is already clean, pre-sorted, and consistent. Once these reverse vending machines reach capacity, specialized collection trucks are dispatched. Large plastic bins, each one brimming with thousands of empty bottles, are hoisted aboard by forklifts. A single truck can carry between 20,000 and 30,000 bottles in one trip, a load weighing approximately 10 to 12 tons, as it makes its way from collection points to the recycling facility. Arriving at the plant, drivers back their trucks up to a massive storage bay and release the entire load. A cascade of glass tumbles out, the sound echoing as the ground fills with sparkling mountains of green, brown, and clear. These shimmering heaps are not an endpoint, but the genesis of the entire recycling process, a vast reserve of raw material waiting to be crushed and reborn. It begins with a symphony of destruction. A mountain of discarded glass, shimmering under the open sky, is about to be reborn. Massive loaders ascend the towering piles of waste, their buckets scooping up enormous quantities of shattered material. They traverse the yard and, with a thunderous crash, empty their contents into the plant's feed hopper. A cascade of shards tumbles down a steel chute onto a waiting conveyor, which immediately begins to carry the stream of glass, dirt, and sand deep into the facility. The first stop is a vibrating screen, where powerful oscillations shake loose the finest particles of dust and grit. Following this initial cleansing, the glass is visibly cleaner, yet larger contaminants that elude simple mechanical detection still remain. Along the conveyor, vigilant workers stand ready, their hands expertly pulling out stray pieces of paper, plastics, and any other foreign objects. This careful combination of machine screening and human intervention yields a pure batch of material prepared for the next phase of its recycling journey. But even now, something metallic still lurks within the river of broken glass: the bottle caps. Fortunately, most are made of steel, allowing for their simple removal by a high-powered magnetic separator. The principle is straightforward. A powerful magnetic field plucks the metal fragments from the flow, while the non-magnetic glass continues onward. Thanks to this crucial step, the stream of glass is now approximately 80% pure. With most contaminants gone, the glass proceeds to be ground into a substance known as cullet. Larger pieces are fed into a hammer mill, a colossal machine where high-speed rotating hammers pulverize the glass repeatedly. Any fragments that remain too large are automatically detected and rerouted through the mill until they achieve the desired size, ensuring the entire stream is perfectly uniform. This process creates a fine, sparkling material that resembles man-made sand. Because it is broken down into such small particles, cullet melts far more rapidly in a furnace, saving up to 40% of the energy required when using raw materials like sand or limestone. From the mill, the cullet is transported to a powerful suction system where it is blasted with a strong current of air. This intense airflow strips away and carries off any lingering paper label fragments. Finally, the cullet moves into the optical sorting system, the most technologically advanced stage of the entire process. As the glass cascades downward like a shimmering waterfall, laser sensors relentlessly scan each tiny fragment, identifying its precise color and composition. The instant a piece of brown glass, green glass, or even a stray ceramic shard is detected, the system fires a targeted puff of air, diverting it into a separate stream. The speed is almost incomprehensible, with tens of thousands of individual pieces processed every single minute. This astonishing precision ensures the cullet is sorted by color with near-perfect accuracy, as even the slightest mixture of a different shade would compromise the quality of the final recycled product. Once sorted, the distinct streams of tiny glass particles continue along the conveyor, directed into separate storage bays divided by color. There, they accumulate into vast, shimmering stockpiles, awaiting their transformation into brand new glass bottles. It begins as a mountain of shattered fragments, waiting for a fiery rebirth. This ground cullet, now a fine powder, isn't yet ready for the furnace. It must first be combined with a precise blend of raw materials. The foundation of this mixture is pure silica sand, the very element that grants glass its signature clarity. Soda ash, or sodium carbonate, is introduced to lower the melting point, a critical step for conserving energy. Limestone follows, lending strength and stability to the final product. Specialized formulas might also incorporate dolomite, alumina, or metal oxides to fine-tune color and other physical properties. Yet, the recycled cullet remains the most vital component, constituting anywhere from 20 to 70% of the total batch. Its presence accelerates the melting process, slashing energy consumption by as much as 40% compared to using virgin materials alone. Even a modest 10% increase in cullet can decrease energy use by roughly 3%, while also making a significant dent in carbon dioxide emissions. Following the factory's precise recipes, the ingredients are thoroughly blended, creating a uniform mixture now prepared for the crucible. This blended material is then channeled into a colossal gas furnace. Inside, temperatures soar to approximately 1,750 degrees Celsius, an environment hotter than volcanic lava. Technicians oversee the transfer as the mixture is poured into specialized crucibles. Within the facility, the ambient heat approaches an almost unbearable 3,000 degrees, forcing workers to don fireproof suits and heavy gloves for protection. As the ingredients begin to stabilize, the mouth of each crucible is sealed, trapping the immense heat and allowing for a controlled, even melt. After 24 hours, the granular mixture has vanished. In its place, a substance flows with the thick, deliberate pace of lava. This brilliant glow emanating from the furnace floor is liquid glass, a dense, incandescent mass that has achieved the perfect temperature and viscosity. For the next 5 hours, the glass is held in this molten state, allowing any trapped gases to escape and ensuring the utmost purity in the final material. To give this liquid form, a mold is essential, and its creation is a science in itself. Engineers employ advanced CAD software to design each mold with microscopic precision, meticulously defining every curve, dimension, and wall thickness to meet exacting technical specifications. From these digital blueprints, the physical molds are forged from cast iron or alloy steel, materials robust enough to endure temperatures reaching up to 1,400 degrees. Once complete, the molds are carefully installed into the double-blow production line. This is one of the most trusted and widespread methods for creating hollow glass products, from soft drink bottles and food jars to pharmaceutical containers. The process ignites as searing portions of molten glass, known as gobs, are dropped into the initial blank mold. Sheared from a continuous stream, these gobs arrive at temperatures around 1,011 degrees Celsius, possessing the ideal viscosity for smooth and uniform shaping. Inside this preliminary mold, a jet of compressed air blasts from above, forcing the pliable glass against the mold's interior walls. This action creates the initial form, a hollow, bubble-like structure with a narrow neck, known as a parison. Still radiating an intense heat, the parison is gently transferred to the final mold, positioned just inches away. Here, a second, more powerful burst of compressed air is injected into its core, expanding the softened glass until it conforms perfectly to every detail of the final mold's inner surface. In a matter of seconds, the complete bottle takes shape. From the outside, the process appears deceptively simple, but behind the curtain of fire and steel, every valve and sensor is synchronized with breathtaking accuracy, timed down to the thousandth of a second. This extraordinary level of control is what enables the production of hundreds of thousands of bottles each day, each one emerging as a near-flawless twin of the last. Fresh from the mold, the bottles radiate a deep crimson heat, their surfaces shimmering like glowing metal rods in the dim light. Robotic arms then sweep in with fluid, programmed grace, gliding effortlessly to their designated positions. Each bottle is lifted with delicate precision and placed onto a conveyor. The entire sequence unfolds in a quiet, synchronized ballet, devoid of any rush or hesitation. The conveyor then slowly carries the newly formed bottles, their bases still aglow, toward the cooling zone. They journey through a long, illuminated tunnel where the temperature is methodically reduced. This gradual cooling, known as annealing, allows the glass to stabilize without shattering under thermal stress. This deliberate stage can last for several minutes, sometimes extending to tens of minutes, ensuring structural integrity. As the journey continues, the cooled bottles arrive at the inspection stage. Here, a sophisticated array of optical sensors and high-speed cameras scrutinizes each one in real time. The moment a defect is detected, be it a crack, a bubble, a scratch, or the slightest warp, the system instantly flags the imperfect bottle and removes it from the line. The next phase of quality control zooms in on the bottle's mouth. An automated system rotates each bottle with precision, while a combination of optical sensors and mechanical probes inspects for any flaw. A chipped edge, a hairline crack, or the most minute dimensional deviation will not go unnoticed. Only those bottles that pass this rigorous examination are permitted to continue down the line. Having cleared every inspection, the glass bottles are conveyed to the palletizing area, where robotic systems once again take command. Engineered for unparalleled accuracy and consistency, these machines effortlessly arrange thousands of bottles into perfect formation. A specialized clamp, fitted with suction cups, descends to grip an entire row, lifting and setting it gently onto the pallet. To cushion against impacts during transit, a protective sheet is inserted between each completed layer. Once the stack is complete, an automated wrapper envelops the entire pallet in protective film and applies a tag, coding it to its specific production batch. These finished pallets are then transferred into storage, where they are neatly arranged awaiting shipment. From this warehouse, they will embark on journeys across the globe, soon to become the familiar, sparkling containers we see every day, filled and ready to serve in countless moments of daily life. It is a shape recognized across the world, a vessel for a taste known by billions. But before it ever reaches a hand, it must pass through a symphony of steel and precision. The journey begins with a baptism of fire and water. High-pressure jets of hot water and steam scour every surface, purging any trace of dust or bacteria. The bottles then glide along a high-speed conveyor to the filling station, where automated nozzles dispense the iconic liquid down to the exact milliliter. Simultaneously, a charge of CO2 gas is injected, locking in that signature fizz. With no time to spare, the filled bottles proceed directly to the capping station. Here, precision machines press gleaming crown caps firmly into place. High-precision sensors integrated into the line then scrutinize every cap for tightness, a critical step to ensure a perfect seal and prevent even the smallest leak. Next, each bottle passes before a high-speed camera system, which scans for any cracks, incorrect fill levels, or misapplied labels. Lined up in perfect formation, the bottles continue their smooth, rhythmic journey, moving like a programmed assembly through each stage. As they reach the water spray station, a high-pressure jet of cold water is aimed directly at the neck of each one. Finally, the perfectly sealed bottles are packed into cartons, loaded onto pallets, and moved into cold storage. They are now ready for shipment to millions of destinations across the globe, from small roadside shops to luxury hotels. A cycle closes, yet the material itself is immortal. The long journey from fractured shard to pristine vessel has reached its conclusion, What was once discarded and broken is now reformed, emerging as a gleaming, perfect object, its value fully restored. This remarkable transformation is not merely a victory for environmental stewardship. It stands as a powerful testament to the ingenuity of modern industry, showcasing a circular process where nothing is wasted and everything can be made new again.